Hello, my name's Gavin Newlands, and welcome to this talk, which is an introduction and demonstration of automotive loadcase setup tools in Oasys PRIMER. And so the contents of today's talk. I'll give you a brief introduction to the Oasys software, then I'll talk through and demonstrate a number of automotive loadcase setup tools available within Oasys PRIMER. So we provide LS-DYNA support to clients around the world, which helps us develop a deep knowledge of LS-DYNA and understand the trends in its use, as well as trends in automotive CAE. Now we also produce LS-DYNA pre and post processors, so Oasys is the software house of ARUP. So these products grew from a need to create, edit, check, and fully investigate LS-DYNA models, and use those models to solve complex engineering design problems. It was created by engineers for engineers. And these tools are now used by many companies worldwide to produce high-quality LS-DYNA models and analyses. So this is an overview of the four main tools that make up the Oasys LS-DYNA environment. First, we have Primer, our preprocessor. Then we have THIS, a graphical plotter designed for LS-DYNA. Next, we have D3plot, which is used for viewing, animating, and plotting all the visual output from LS-DYNA. And finally, we have Reporter, which adds the ability to automatically produce reports for your LS-DYNA analyses. Okay, so let's go through some of the automotive loadcase setup tools available within Oasys PRIMER. Just a diagram first to show where Oasys PRIMER fits in the LS-DYNA workflow. So Primer is used for all model assembly and setup, checking and loadcase setup. And today we're specifically looking at the loadcase setup tools that are available. So Primer contains many tools that help the setup of automotive analyses. And these tools help to provide consistent setup processes, which can lead to higher quality, error-free models. And often these tools are used as part of an automatic process to create many models at the click of a button. Firstly, let's talk about the barrier positioning tool that's available within Primer. So the barrier positioning tool, which in Primer is called Crash Test Setup, is a tool that allows you to position barriers according to the rules in various regulations. And it provides a consistent way of positioning your barriers to eliminate human error. So many load cases are included with the standard installation of the Oasys LS-DYNA environment, but any number of other load cases or variations on load cases can be added as well. So for example, you may have some internal company tests only used by you that you would like to add into this list. Let's go through a demo of Crash Test Setup. To access Crash Test Setup, go to Tools, Safety, Crash Test Setup. Now in the first panel that appears, you want to select the model you want to position a barrier to. So here you can either select the model already read into Primer or a model on disk. Here we'll just select a model on disk to read in. Then you click on Next. And the next panel shows you a list of the available tests that you want to set up. As you can see, there are a variety of regulations and tests included. The test specified can be filtered at the top of the panel, either by selecting the column headers, or you can use the text filter at the top as well. So if I type in front, you get a list of the ones that mention front impact. So when you select a test, here I'll just select the ODB front impact. You have some inputs on the right-hand side. So you can choose whether it's a left impact or a right impact. You can choose the velocity magnitude, the offset, and so on. Now, I mentioned previously you can save your own tests in here as well. So let's say I wanted to set up a test that's similar to the urine cap offset test, but a slightly different offset and a slightly different velocity. I can save that into the Crash Test Setup database as a custom test. And that means that that test will now be available to you in future sessions of Primer and also available to other members of the team using Crash Test Setup. For now, I'm just going to run the standard Euro NCAP front ODB. So I'm going to select that. This is the test I want to run, and click Next at the top of the panel to go on to the next screen. So this next panel is where you specify certain information to help Primer position the barrier. You only need to specify this information once per vehicle, as the information can be saved into the Crash Test Setup database and reloaded in the future. So let's just have a look at some of the inputs on here. It's things like vehicle driving direction. Is it in the positive or negative X direction? Certain part sets that Primer needs to know information about to position the barrier. The set for the initial velocity, where you want the initial velocity to be applied. Then information on ground planes and the vehicle center line and wheel axis, that sort of thing. So once you've specified all this information, as I said, you just do it once. You can save that information out using these buttons here. So note that the information is already pre-populated in this example. And this is because one option is to save the metadata after star end in your LS-DYNA model. That way the information stays with your model. Note you can click on any of these question mark buttons and get more information about what information Primer's looking for here. So once you've set up all this information and saved it, you can click on Next. Next, we have the barrier. The idea here is you save all the barrier models you use into the database, and Primer will tell you which default one to use. This allows you to ensure the correct barrier models are being used in your analyses. You can optionally select a separate barrier from disk as well. Here, I'll just import the default barrier. When importing, you get the option of changing include label offsets. I'll just choose the default here. Here you can see the barrier has been read in and it's in its standard position, so it hasn't been positioned against the vehicle yet. So back to the panel. As with the vehicle, you have to specify certain information for the barrier to aid positioning. And again, this information need only be specified once, and then you can save it into the database using these buttons or with the model. Once happy with the information specified, click Go, and Primer will position the barrier against the vehicle. At the end, you get a summary of information. So information about initial velocities that are being created, contacts that are being created, and so on. You also have the option of saving your model out here if you want, or you can just go and have a look at it in Primer. So here you can see the ground plane is being created, and I can plot initial velocity to show that it's created the initial velocity cards required. So now we have the model, and I can write it out and run it. So hopefully Crash Test Setup gives you a consistent way of setting up and positioning your barriers for crash test analysis. Now I wanted to also mention model build at this point. So the model build tools within Primer have similarities to Crash Test Setup, but it's a more general tool for building models. So Primer includes the ability to create a database of include files, and this database can then be used to build models for different load cases using the same vehicle model. So again, it provides a consistent way of building your models to ensure everything is correct in the models that you run. So the database contains all the include files you could use across all your load cases. And then template files for each load case specify which includes to use. Version control is also available with this feature. I'll just show you a quick demo of this. Okay, so to access the model build functionality, you go to Model and then click on Build. And there's various options in here. If you're starting from scratch, you'll want to build a database of include files. And you can do that using this drop-down. And the easiest thing to do is to create a database from a directory or maybe include files in a model that you already have. Now I've already got one set up here, so I'm going to select that database. here, very simple one. I'm going to select that in this panel, click apply, and it reads the database in. So here we have a tree structure split up into different sections, which is completely configurable by you. If I expand it, you can see all the different include files or entries in the database. And I can select these. So there's some control cards in that one. This one's the body in white, and the powertrain, and so on. So let's see if I select, let's select a barrier, and then I'll select a seat and a dummy. I can click apply, and Primer will build that model. Now, when it's building the model, it does some checks, and here we're seeing a report of some things that it might have found in the model that might be incorrect. But essentially, it's chosen those include files in the database and built the model. Here we go. Right, let's just delete this model and go back into the model build panel. Again, we've got our database. If I expand all that, let's just have a look at what's stored for each entry in this database. So here for the body in white, obviously there's a link to the keyword file, the actual include file that relates to this. But there's also version control as well, so you can have different include files linked to different versions that you want to build. There's also extra data here, so that might be connections to different include files and so on. So other include files you can store with this entry. There's also a section on orients here. I'm not going to show that today, but you can specify orient points that helps you position different include files to other include files when you're building the model. Now, instead of ticking these entries, you can specify a template. So I've read in a roof crush template here, and that essentially just ticks the various different entries in the database that are applicable to a roof crush analysis. So here down here, you can see in the load case section, I've got the roof crush load case. So I build that model. Here you see we've got the body in white and the plate that's going to be pushed against the body in white for this analysis. Right, let's delete that model. Go back into model build. Another thing you can do here is use the template panel. So this is where you can view and set up multiple templates at once. On the left-hand side here, we've got all the entries of the database, and then across the top, we've got the templates. Now, if I just read a template in from my directory here, it will search through the directory and read all the other templates. So I've got 3 templates here, an FFB, IHS, and Roof Crush. And you can come in here and select which entries in the database are applicable to each load case and save that out. But also from here, you can build these models. So I've got 3 models here that I want to build. I'll build them in Primer. You can specify just to write them out to disk rather than reading the data into Primer. Click apply. And again, it does some checks as it's going through here. So it'll point out some problems that I think there might be in the model and when doing the model build. And here you can see, if I just quit out of these panels, I have 3 models. So I've got my roof crush model, my IHS, which includes more vehicle components, and then my FFB as well. So this is a useful tool to use if you have all your include files set up, maybe all your barriers pre-positioned, and you want a way of managing all that data and building your models in a consistent way, which also includes version control. Okay, so let's have a look at the tools in Primer related to pedestrian protection. So there are a few tools in Primer that help with the pedestrian protection analysis process. Now in this presentation, I won't go into them in any great detail, but I'll give you an introduction to the tools and their functionalities. So first of all, we have the markup tool, which gives you the ability to mark up your vehicle according to standard regulations to determine the impact zones. And then tools that allow you to define points within those impact zones and automatically position and depenetrate your impactor in those zones and write out and create multiple analysis really easily. And we then have tools for visualizing the results and calculating areas of hit and calculating your NCAP score. And then you can do some analysis on those results as well. And this applies to both head impact and leg impact. So one tool I wanted to mention that doesn't live with the rest of the pedestrian tools is under measure. So this is the distance plotter. And this allows you to plot the distance between components in your model. And these can be calculated along different vectors. So it's quite useful for, say, a head impact in pedestrian protection to measure the distance between the bonnet surface and the harder components in the engine that sit below it. So this tool can be used to do that. Okay, so let's just demo a couple of these tools. So let's have a look at the Pedestrian Markup tool. This is the tool where you can calculate impact zones for pedestrian protection analysis. This is a typical model where we have the front end of a vehicle, we have components modeled underneath the bonnet surface. So if we go to Safety, and then Pedestrian, and Pedestrian Markup, we have this panel. So this is similar to other panels in Primer where you can specify certain information that Primer needs to perform the calculation. So the first thing we want to do here is to select the outer surface parts. So these are used by Primer to calculate things like wraparound distance lines and so on. So once we're happy with that selection, we click Apply. And there's various things you can change on this panel now. So for example, wraparound distance, these are set to the protocol defaults, but you can change those if you wish. And the red buttons here are things that you now have to provide more information for. So the bumper parts here are required for the Euro NCAP protocol, as is the bumper beam parts. So I'll select that. And then for the bonnet rear reference line calculation, we need to specify the bonnet parts and the windscreen parts as well. Okay. Now you can save all these settings out to a file and read them in at a later date. As I said, you can change the protocol here as well. And there's also an option here for changing the angles used in the calculation as well. So you can change those if you wish to. Once you're happy, you can click Apply and Primer will perform the calculation. So this takes a few seconds to run through. So Primer is calculating the wraparound lines, the various bounding lines required to calculate the impact zones. And here we go, this is the result. So as you can see here, Primer's created a couple of new models. So it hasn't changed the original model, but in this new model here, we can see the impact zones modeled as beams, but here we can also see all the working out. So you can save that out as well if you want to. So you can see here the panel has changed as well. And this is where we can sketch impact points within the calculated zones. So that's the head points, and it's just a cloud of points a certain distance apart. Same thing for upper leg and lower leg. You can, of course, change the distance between these points as well. And then this is the lower leg down here at the bottom. Yeah. So let's just have a look at the head for now. And there's various different options here for modifying the points that you want to set up analysis for. So this option, pick default green point parts, relates to the protocols which say that if you hit the bonnet, then if you hit the windscreen, then that's an automatic green point. So you can specify the windscreen part here, and you can see they go green. And then there's options for adding more points to this, as well as the cloud. So we have create manual. You can just click a point on the screen to create a new target point, impact point. And then this hard points tool allows you to select parts, hard points underneath the bonnet. So I'm just going to select this brace here. And then Primer can calculate, based on those hard points, impact points on the surface, projecting back along the line of flight. You can also contour it, as you can see here. So you can pick a particular point on this hard point and Primer will project it back to the surface, or you can ask Primer to automatically detect any number of points that are closest to the surface along those hard points. And that's what I'm doing here. 2 points have been found that are closest to the surface on those selected hard parts beneath the surface of the bonnet. So that's some extra points that I've added there now. You can also add robustness points, which adds a cloud of impact points around selected impact points that already exist. And there's also an option to write the boundaries out in a variety of different formats. The bottom section of this panel all relates to writing the information out. So you can write this information out as a CSV file, either the child or the adult points that I'm showing here. But then you can also set up the model build process through here. That's where you define what the impactor is and the analysis parameters and so on. I'm not going to show you this here because I've got an example later on related to interior head impact, but the process is pretty similar. But essentially what Primer will do is take the impactor, in this case it'll be the headform, position it on the impact point and depenetrate and try and minimize the distance between the initial contact point and that specified impact target point. So there you go, a tool that makes it very easy to calculate the impact zones for various protocols for pedestrian protection. So now let's just have a quick look at the pedestrian HIC area calculator. We have a very simple model here. And we go to Safety, Pedestrian HIC Area Calculator, get this panel. And this is where you will read in some HIC results, probably a CSV format, and you can visualize those results in your model. See where there might be problem areas and make some changes accordingly. It also allows you to do some analysis on those points as well. Let's just read some data in. This is essentially just X, Y, Z coordinate and HIC value, and it plots them like this. You can change the low HIC, high HIC boundaries as well. There's various different graphics options here for turning things on and off. So at a basic level, you can just see where your problem areas might be. But then you can click on the Calculate Area. This is really for the GTR regulation where you want to calculate area of HIC. And as you can see, it's projected that down to a flat surface, but you can then project those results back up to the bonnet if you want to visualize it a little bit better. So there you go. This is the area of HIC as calculated from those impact points. And you can see it's calculated the percentage area that's green and so on, which is what you need for the GTR calculation. There's also calculations for calculating the Euro NCAP point scores as well. But there's different options here. These are options for changing individual points to see what effect it has on the area. And then there's analysis tools. So band sensitivity allows you to see which points are close to getting better or worse, which you might want to know about because it changes the areas of HIC. And then area sensitivity is a tool that looks at all the impact points and tells you which ones would be best to try and look at in terms of reducing HIC, because that will have the biggest effect on improving your areas of HIC. There's lots of different functionality in this tool and it's really useful. So please do have a look at it and look in the manual for more information on this tool. Okay, moving on to interior head impact, which covers everything related to FMVSS 201 upper. So Primer has tools to determine target locations on the interior trim according to the FMVSS 201 regulation. There are also tools to automatically position and build models based on those target positions. And finally, there are also tools available for you to interactively position your headforms to target positions. So let's see a demo of that. Okay, so here we have a model we might want to do some interior head impact analysis on, and we want to mark it up, so calculate all the target points according to FMVSS 201. So if you go to Tools, Safety, Free Motion Headform and Free Motion Headform Markup, you get this panel. And on this panel, you go through a series of steps to specify the information that Primer needs to know to calculate the target points. So things like seating reference point and so on. And you can specify which points you want to calculate, so A pillar, B pillar, R pillar, front header, etc. Now, once you've specified all the information, you can save that out as a settings file. So here I'm just reading in a previous settings file that I've set up. And as you can see, all the information has been populated on this panel. And now you can step through a series of panels where you can specify the information. So this is all the information required for the A pillar input. So things like what's the outer roof, and what the A pillar interior parts are, and so on. And you can sketch and see what has already been selected as part of this settings file. So here we can click through. This is the B pillar input required, R pillar, front header, and so on. So once you get to the end and all the information has been specified, you can write that settings file out at this point. But then you just click on the Calculate and Visualize button, and that goes through the calculation process using all the information that you've specified to calculate the target points according to the regulation procedure. Here you can see all the points have been calculated, these green blobs. So we've got A pillar, B pillar, and so on. And they're all presented in this table here. So you can write this table out as a CSV file, or you can do various things here. You can change the information in here as well. The Visualize buttons on the right-hand side allow you to visualize the calculation procedure. So these are the planes, reference planes that have been calculated. And then the little question mark button shows you a diagram showing how those target points have been calculated. So you can see the workings out. There's also a button here to create your own manual points, so you can just pick them from the screen. And there's also a robustus points button here where you can create a cloud of extra points around particular target points if you wish. Now, what do you do with this information when you've got it? Well, you can write it out, as I said before, as a CSV file, and that can be fed into Primer's model build functionality, which I'll show you in a little bit. You can link to that directly from this panel. So here we go. As you can see, this tool is used to mark up the vehicle and calculate the target points applicable for interior head impact and for the FMVSS 201 upper regulation. So let's have a look at the manual setup tool for interior head impact in Primer. So this is, let's say we take this model, we've got a model read in, and we've got a head form and a bit of a vehicle. If you go to free motion head form, manual setup, you get this panel. And the first thing to point out here really is the top section where we have setup targets. So if we click on this, this is where we can specify our target positions. So this might come from the markup tool, or it might come from an external source, or you can just type them in. You can specify any number of target points here. And specify ranges of horizontal and vertical angles as well. So once you've got all your target points in here that you want to look at, you can start positioning your head form to these target points. So here I've got a few set up, and I'm currently set to BP1, but I can switch to AP1. And as you can see, Primer will automatically move the head form to that point. This is a really easy way of moving your head form around to different positions without going into the Orient tool and rotating and translating and so on. So let's stick to BP1. Here you can see we've got a button that checks for penetrations. So here you can see I have got some penetrations between the head form and the body. I need to do something about that. Now here we've got the current head form position. So you can store any number of positions for each target point. Here we've got one. So if we go into the position panel, this is where you can move the head form around and set the position. So you can specify the horizontal and vertical angle in here. And there's useful tools that allow you to easily move the head form around in a way that you might want to move it around for this particular type of analysis. Here I'm moving I'm dragging the head to move the to change the vertical angle. So let's say there's also a button here called Max Hick. What this does is it rotates the head round and tries to find out the vertical angle position. That would mean that when you strike whatever you're striking, the head would rebound directly, and therefore that might lead to the maximum Hick value without there being too much rotation. So down the bottom here, we have tools for depenetration. You can change which direction you can depenetrate. So you might depenetrate just along the x-axis, local x-axis, or plane, or completely unlock it. So I've just completely unlocked it there. And when it depenetrates, it tries to move the headform to minimize the distance between the target point and the impact point. Now we've also got a tool called the auto vertical tool, which I'm showing here. What this does is, if you specify a shell set for the chin, Primer will rotate the headform around the target point until the chin touches the trim, and then rotates back by the back angle specified on this panel. And this is to simulate the procedure that's in the test for setting your vertical angle. So you can see it's done that, rotate the headform around until the chin touches and then rotates back. So you can use this panel to set your vertical angle, horizontal angle, position your headform as close as you can so the contact point is as close as possible to the target point. And once you come out of here, you can then run a check. So this is a check tool that runs through a check on all the current positions that you have, checks for penetrations and so on. So here we found on AP1 there's a penetration. So I can come into the positioning panel, depenetrate again, auto position, and it comes back with the result here. Now, as you can see here, the distance to target is quite far away, so it's 11 millimeters away. And so this is indicating that for this particular combination of vertical angle and horizontal angle, that we can't quite reach the target point. So you might want to think about changing the horizontal and vertical angle there to try and achieve the target. So there we have it. This is a tool that allows you to modify the position, vertical angle, horizontal angle of the headform, and automatically depenetrate and move the headform to get as close as possible to that target point, excuse me, and do it in a very interactive way that's natural for this particular type of analysis. So let's talk about the multiple model build aspect of interior head impact, which is accessed also through the safety menu. Now, this is the same as the pedestrian impact process that I mentioned earlier. So I'll just demonstrate it here, but as you can see, you can choose pedestrian head, pedestrian leg, and so on. So for interior head impact in this case, there's various inputs you can specify in this panel, or you can read target point information from a CSV file. That's what I'm going to do here. And the CSV file in this case also contains reference to the vehicle and the head impactor, as you can see. So just click on Make here and it'll read in the vehicle model and the head impact model. You can see there, the head impact model is in its sort of standard position. So now if I click on Edit Load Cases, you can see the target points. Now this can come directly from the markup tool that I showed you earlier, or it can come from another source. We have all the XYZ target points, horizontal angle, vertical angle, velocity. There's various other inputs on this panel. So here is the depenetrate option. So if you want Primer to automatically depenetrate the impactor when positioning, you can do so. And there's various options down the bottom for where you want the information to be written out when you're building these models and so on. So I click Apply. Primer is now going to move the impactor to all the target positions at the specified horizontal and vertical angle and depenetrate. So when it's depenetrating, it's checking to see if there's any penetrations first of all. And if there are, it will try and position the impactor so that the initial impact point, initial contact point, is as close as possible to the target point. And there's options to change that functionality as well. As you can see, it's moving to all the different points. So as I said, this model build functionality can be accessed directly here, or it can be accessed from the markup tools, either interior head impact or the pedestrian impact tool I was showing earlier. So the process for pedestrian is exactly the same here. You can imagine the pedestrian headform being moved to various different target points on a bonnet surface. So now it's finished. It's built all the models. You can see all these models are in Primer here. It's also written these out to disk. So there you go. All these models being created, positioned, depenetrated. And Primer doesn't create copies of the impactor here. It'll create the include transform information required to move the impactor from its standard position to the final position as calculated by Primer. So let's now have a look at the IP Pendulum tool in Primer. So the IP Pendulum tool is used to set up pendulum impacts into the instrument panel in your vehicle. And it relates to FMVSS 201 as well as ECE R21. As with other automotive impactor tools, Primer will create multiple analyses at different impact points and automatically position, depenetrate the impactor and create the output files required. Just a note to say that the IP Pendulum model for use in Primer can be downloaded from our website. If you go to Products, ARUP Pedestrian Impactor Models, and choose the IP option on the left-hand side, you can download the model. So that can be used within Primer to set up these types of analyses. Okay, let's move on to a demo. So here we have a model read into Primer. We have an IP mesh, and we have the Pendulum model downloaded from our website, included as a separate include file. And I can just plot the initial velocity here, and you can see that we already have initial velocity in there. So I want to specify some target points here on the instrument panel. So I go to Safety, IP Pendulum, and I get this panel at the bottom right. Here you can specify certain things in the model, the contact between the pendulum and the IP, the velocity. There's some presets in here already. The H point where the pendulum is located, either in its forward or original position. And then there's a settings button where you can change things like the max extent of the rod or the min extent of the rod. These are set to the test defaults, but you can change them if you wish. Down the bottom are some options for the particular type of test that you're setting up, be it ECE R21 or FMVSS 201, because they're slightly different. Once you're happy with the setup, you click on the targeting panel, and this is where you can specify your target points. So you can, if you wish, pick them from the screen. So I'm just picking one now. Now Primer does some basic geometric checks, and here it's determined this point is too far, so the pendulum will not be able to reach that point. So let's just remove it. You can as well read in a CSV file of data if you have the targeting points from a different source, or if you don't have any information, you can use the tool here for Primer to create a cloud of points on a specified mesh. So here we have a number of points that's been specified on the part that I've selected. So all these parts can be reached, so none of them are red, but the light blue means the angle between the trim normal and the line of flight exceeds 45 degrees, which likely means a glancing blow. So those ones you might want to remove from the list. So we can do that here quite easily. We can select them by angle and remove them from this list. Okay, so we have a list of points now. So now what we might want to do is to actually see whether the pendulum can impact those points. So we click on Position, and Primer will move the pendulum and try and place it on those target points. So it'll depenetrate and move to minimize the distance between the pendulum impact point and the specified target point. Sometimes the shape of the trim means that you won't be able to contact some of the points that you have specified. So here's the result, and you can see the green ones it can reach, but the red ones it can't reach, probably because of the shape of the instrument panel. So again, we can select those points and remove them from the list. And we're left with a cloud of points that we can actually reach with this pendulum. So now you can write this information out if you want, or you can use Primer to write out input for LS-DYNA. So all these models you can write out, and Primer will write out positioned pendulum models. So it will move it to the specified position, and you can write those all out from this panel. So when you write those models out, this is what you'll get. So here you can see we have a series of directories, one for each impact point. And in here you can see we have the master file, which is the one beginning with node, and then the impactor, which has been written in the position that Primer has determined. So now let's look at the tool in Primer for ejection mitigation. So Primer has a tool for running through the procedure specified by FMVSS 226, ejection mitigation. So here you specify a few things in your model, and Primer will calculate the targeting points for this test. Let's see a demo. So here we have a very simple model. It's the front glass of a door and the surrounding parts. And we're going to go to Safety, Ejection Mitigation, and we get this panel where you can specify the inputs for the calculation. As with other panels like this, you can save the inputs in the settings file and read them back in at a later date, so you only need to specify them once. But let's go through these settings here. So we can specify that the vehicle is pointing in the positive X direction, and we want to do the calculation on the forward window. We specify the parts that surround the glass in the door, and now we specify the door glass itself. And that's all that's required. There are a few other settings here you can change to tweak the calculation, but this is all we need. If we click on Calculate and Visualize, Primer will now go through the steps as outlined in FMVSS 226 to calculate the target points for this test. There you go. So the calculation is drawn on the screen, and the coordinates are shown in the panel. So here we have some options for offsetting those points and outputting the result as an image. We can also write this information out as a CSV file, or it can feed into Primer's model build functionality to automatically position impactors at those points. So this is a tool, a very simple to use tool that makes the complex steps involved to calculate the target points according to FMVSS 226 very easy to do. So now let's look at Seatbelt Anchorage. So the Seatbelt Anchorage tool in Primer positions loading devices and sets up an analysis according to ECE R14. So let's have a look at a demo. So here we have a model read into Primer. Typically this would be a sled model for Seatbelt Anchorage. Might include a bit more than we have here, but here we've got the floor, seat, door, and part of the B pillar. So if we go to Safety and SBA Automation, we get this panel. And again, similar to other panels that we've seen, you specify certain things that Primer needs to know to be able to set up this types of analysis. So things like the point on the B pillar you want to attach to, seat foam, and so on. Down here you can see you can also specify things to set up inertial loading on the seat, which is part of the test as well. I can save everything out to a settings file, so you need to set it up once. So I've done that here. If I read this settings file in, populates all the fields, as you can see. And I can have a look at these fields, I can change them, I can sketch them, and so on. So once I'm happy with the input data, I can go to the next stage, which is applying the inertial loads, and you can do this if you want to. You can optionally turn it off. I've got it turned on here. I'm just missing one piece of information here, which is a part set that defines all the parts around the back of the the seat. So specify that. Now calculate is available to me, so I can click on that, and Primer goes away and sets up the analysis. So it brings in the standard blocks. These are included with Primer. Brings them in, and as you can see at the minute, it's positioning the inertial loading device. And now it's positioning the blocks into the seat and into the correct location according to the regulation. And then the final step is to fit the seat belt you see here around the blocks. It's also creating the appropriate loading at the end of these seat belts that are going to pull the blocks during the analysis. So that's all set up now. As you can see, the blocks are in position, the seat belt's been fitted around the blocks. We can now write this out of Primer and run the analysis in LS-DYNA. So let's look at luggage retention. The luggage retention tool is a tool that brings in some standard blocks and sets up an analysis according to ECE R17. So let's have a look at a quick demo. So here we have a very simple model, just some seats. That's all we have in the model. So to set up a luggage retention analysis, we go to the luggage retention tool. Very similar to some of the tools I've already shown you today. And again, you specify certain things on this panel that Primer needs to know to set up this type of analysis. I'm going to read in a settings file here that contains the information required to populate this panel for one that I've done earlier. There we go. And what Primer is doing here is creating the reference planes applicable to this particular analysis type, and also brings in the blocks to position against the seats. So here you can see it's creating the planes, bringing in the blocks, positioning them against the seats, and then a ground plane at the bottom, which the seats are attached to. And it also creates the boundary prescribed motion that applies to the ground plane that's required for this type of analysis. So there you go. The blocks are included with Primer, so very, very easy to set up this type of analysis in Primer. I just wanted to finish today by talking a little bit about automation. So most Primer customers are using automation to make their processes faster and more reliable. And new and improved automation is one of the biggest areas of Primer development. So we've got automation of some of the tools we were looking at today, automation of checking, automation of connection creation, and so on. So the heavy detailed work done by Primer can be automated. So what you might have is a script that drives the functionality of Primer. And that functionality can be a number of different things. So why use Primer for automation? Well, 100% comprehension of LS-DYNA data and can handle complex data without errors. And Primer has all the necessary functionality already. You can call the tools within Primer as part of your process. It has powerful automation and customization capabilities. So we have our internal scripting language. We can run macros and so on. And automation scripts can be created by customers to match in-house processes. Automation is a key goal for the Primer development team. Capabilities are always increasing. And there's many successful examples of Primer automation by OEMs. So just run through some of the tools in Primer that support automation. So we've got bill of materials. So reading in material thickness information from a CSV file and applying it to your model. This is a function that can be called in batch mode and can be called from a script. And Primer can create Spotwelds, Adhesive, bolts using connection files. And this data is usually available in a CAD system or a PLM system, and Primer can read that information, translate it, and convert it into the LS-DYNA representations of connections that you want in your model. Bolts, again, same as Spotwelds and adhesives, Primer can create the relevant FE for the way that you model bolts within your company. Mass control. So there's several tools in Primer available for measuring and controlling and creating mass. So Primer understands how LS-DYNA calculates mass, including mass scaling. And the assign mass tool can set the mass and C of G by automatically adding lump mass elements. And this is also available in batch mode and can be called from scripts. Numbering is a very important part of the model build process, and Primer can apply any required numbering scheme. Of course, model check is a big part of why people use Primer, and the checking can be commanded by a script and be incorporated as part of an automatic process. For example, you may build Primer into your process for submitting analyses into LS-DYNA. And if it doesn't pass the Primer check, then it doesn't submit it. And of course, Primer's checking can be customized. So certain checks can be turned off if you want to, or you can add your own checks into Primer's checks. And of course, we have automatic reporting. Reporter includes ready-made report templates for various load cases. And that can be built into an automatic process as well. And just a note on scripting. The Oasys software has an embedded scripting language based on JavaScript. And it gives you the ability to create your own tools, save time on repetitive tasks, reduce errors, specify a process for others to follow, and much more. And it gives you access to Primer functionality, such as the Loadcase setup tools. And so combining together Primer's model setup capabilities with scripting as part of an automatic process is a powerful way of producing quality models in a repeatable way. So many of the tools mentioned today are available to be incorporated into an automatic process. So for example, coupling Primer with a PLM system to automatically build, connect, and check vehicle models. Maybe an automatic process to mark up a new vehicle for pedestrian protection, position headforms, and create many analyses. Automatic post-processing is then available afterwards as well. Of course, occupant positioning and setup can be incorporated into an automatic process. And then maybe multi-model assembly, so multi-barrier positioning for different load cases using the same vehicle model. So just to summarize, Primer contains many useful tools for setting up automotive analyses for a variety of different load cases. The easy-to-use tools enable you to get your analysis running quickly in a consistent way, reducing errors. And the tools can easily be incorporated into your automatic process to ensure quality models are produced quickly and robustly. Finally, do visit our website for more information on our products. You'll also find a library of past webinars that I'm sure you'll find interesting as well. And please do get in touch with your local distributor for support in using our software. Thank you.